Welcome to the future.
Well, hello there. This is Ali from the AI Enthusiast, and we're kicking off the AI Fundamentals tutorial series. So I'm really excited to be starting this tutorial series. Actually, this was my intention, like one of the things I wanted to go over like a very long time ago, like 3 or 4 years ago, just basically covering like the fundamental technologies and the math behind the theory behind machine learning and artificial intelligence. So I'm really excited to start this. The first topic we're going to be learning is linear algebra. It's probably one of the most, if not the most important topics to know when you're talking about machine learning and artificial intelligence. So I made this notebook and it's going to be available in the description. Take a look at it. So the prereqs for this the series, you should have already taken linear algebra, but even if you haven't, I'll try to cover like the basics. And, you'll realize like just knowing the basics is good. And then, in the future, when we actually start doing practical machine learning and deep learning applications, you'll know, what you'll see is like there's not, you won't necessarily need to know all this, but at the same time, I think it really does enlighten folks to know the fundamentals. So anyways, I've spent so much time just kind of introducing it. Let's just jump right in. So we're going to be using Numpy, which is and Python programming language. So Numpy is a way for us to manipulate vectors and matrices. So and if you don't know what that is, I'll kind of go over it in high level detail here. But I'm just going to go ahead, Shift Enter. I'm going to go ahead and execute this. And now I've imported the library. So step 1, matrices and vectors. So I'm just going to go ahead and execute this. So if you have a Python background, you're good. You can just look up NumPy and what this is doing, these function calls. But essentially, the first one, we're generating what's called a matrix. A matrix is essentially, you have a list right here. This is a list of numbers. So if you have a 2-dimensional list, right? So now we have, this is going in 1 dimension, but now we're going, this was x-axis, right? And this is like the y-axis. So now you got 610, 053, 510. This is a 3x3 matrix. That's all it is. Just think of like an Excel sheet or a table. This is a 3x3 table, and this is a 3x4 table. That's B. And then you'll see C here is actually what's called a vector. So a matrix that has 1 as, like if it's only a column, a single column or a single row, then we call it a vector. So yeah, you can see here, that's pretty much the first bit right there. So step 2, taking transpose of a vector in a matrix. So you know how you can take transpose of like Excel tables and Excel rows and columns? It's the exact same thing. So actually, if I execute this, you'll see the original matrix A is like this. Now if I flip it across the diagonal. So now 904 should be going downwards. And then after that, 038 will be going downwards. And then 050 will be going downwards. When you see the transpose of it, you'll see 904 is going down. And then the second row is now the second column, 038. And then the third row is the third column, 050. So you've essentially flipped it. Yeah, pretty neat stuff. And then the vector, if it was a row before, a column before, now it's going to be a row because you're flipping it. So yeah, that's all it is to transposing. It's just like doing it in Excel. And then finally, you can multiply matrices and vectors. So again, definitely take a look at linear algebra, look at your theory, there's a bunch of excellent videos online that you could be watching for linear algebra. This is a summary, but basically you can double all the values inside of a matrix. So you'll see we have A here, right? So if I execute this, yeah, A was here. So I can just show A. I can just print out A real quick. So what we did here is the first is just doubling it. Everything in A, just double it. So when we see A doubled, this was 610, so now you see 1220, and likewise for everything. And then you can also do the same thing with the vector. So remember C was a vector, so if I go to C, I can press enter. C is this vector 522, and over here in this row, in this column, in this code, you can see we've multiplied it by 3, so you got 15, 6, and 6. So yeah, you can multiply vectors and matrices by what's called a scalar value. So basically a scalar, just like you have a vector has 3 dimensions here, you have 3 different values. and this is a 3 by 3 dimension matrix. Well, a 1 by 1 dimension, like a vector of size 1 or a matrix of 1 by 1, that's just a scalar. Like it's just a regular number. So that's what we're saying by multiplying by a scalar. And you can see we multiplied it by 2, which is a scalar, and then we multiplied it by 3, which is a scalar, and you saw the results here. I'm just going to show a vector by vector multiplication. So if I do np dot, so if I have b vect, I can just show you guys. This is what b looks like. And what I can do is I can do np dot, and I can do b vect with b vect. So you can multiply vectors. I probably should show that first. So this is not to worry. We can just go ahead. Ignore the little logic there. But you'll see you have b vect, and then and I'll print b vect dot t. So we have b vector, and then dot t just means we took the transpose, right? You'll see in the code above. So basically we took this column and we made it a row. And so these are the things we're multiplying. And the way we multiply, the first element maps with the first, the second element with the second, third with the third. You multiply them and then you add them. So 1 times 1 is 1, 2 times 2 is 4, 0 times 0 is 0. So 1 plus 4 plus 0 is 5, and the result is 5. So when we're doing this vector by vector multiplication, that's when we're doing a matrix by vector multiplication. That's exactly what we're doing. We're actually just taking it vector by vector. So a matrix, take the first vector, then multiply it by this vector, take the second vector, multiply by this vector, and then take the third vector and multiply by this vector. And that's why you get 3 results out. It's a 3 by 1 vector. Okay, so now that we've done that, so let's move on to step 4, guys. Multiplication of a matrix with a vector. So you can actually multiply these things. So you have here, I'm going to go ahead and press enter. So you'll see a matrix can have values between, like you can see, it's got 1, 2, or 0. And then you have b vector, and this is a column. So what you do is it's a times b. And what you're going to do is you have to have the dimensions line up. So you'll see the 3 by 3 is saying we have 3 rows, and each row has 3 columns, like it has like 3 elements, right? It's 3 by 3. And then you have a vector, and this vector, remember this vector is a column. So it's 3 rows down and then 1 column each. And that's why it's 3 by 1. You multiply this out. The inside dimensions have to match for matrix to vector multiplication, 3 by 3. So like this, what you do is you just delete this and you're left with 3 by 1. So if this was like a 5 by 3, then you'd be left with a 5 by 1 vector, because these two cancel out in the middle, 3 by 3, and then you get 5 by 1. So anyways, to do this calculation, you're going to take each row of the first, like the matrix, and you're going to multiply it by the column. So 1 times 1, 2 times 2, and then 0 times 0. So imagine if I had taken this row, transpose it, now it would be a column. So right next to it I have 1, 2, 0, and then I'd multiply them element by element. I get 1 times 1 is 1, 2 times 2 is 4, plus the 1 is 5, and then 0 times 0 is 0, so it's 5 plus 0. You just take the inner product between the matrix and the vector, and you're left with 5, 3, and 2. So yeah, guys, this video has gotten pretty long, so I am actually going to pause on number 4, and I will start 5 in the next video. So yeah, guys, as you can see, it's not that hard. We just kind of covered the basics of linear algebra. What is a vector? What is a matrix? How do we multiply these things? And, how do you take the transpose? So I encourage you to review this code, and wait till the next tutorial for more information. And eventually one day when we go through all this math and we've done it, then we can start doing some cool things with it. And I'll show you that with, like, we can do image manipulation, we can do audio manipulation, we can do all sorts of cool things. But right now we're just gonna, at a high level, introduce you to the basics. So take care, have a good one, guys.